Think about this for a second. Every time you use a pencil's eraser, it gets a little bit smaller, right? Well, believe it or not, something very similar is happening inside your body on a microscopic level. Deep inside your cells, your chromosomes have protective caps called telomeres. And just like this eraser, they get a little bit shorter every time your cells divide. But unlike your pencil, when its eraser runs out, it is called red. The reason for this is the end replication problem. The machinery that copies our DNA can't quite reach the very tip of the chromosome, so with each copy we lose a tiny bit of the protective telomere. If this continues on, our telomeres will become too short, telling the cells to stop dividing and ultimately making us age.
Oh no.
But wait, there's a hero! A remarkable enzyme called telomerase. Think of it as a tiny, specialized machine whose job is to rebuild that protective eraser at the end of our chromosomes. Using its own internal blueprint, telomerase can extend the telomeres, essentially hitting the reset button on the cell's ability to keep dividing. No wonder why most of our adult cells have such a limited lifespan. The telomerase is mostly inactive, but in stem cells, which need to constantly renew their tissues, telomerase is hard at work. Now, here's where things get really interesting. And a little bit dark. Most cancer cells manage to reactivate the telomerase, giving them the ability to become immortal villains and fueling the growth of cancer's tumors. This is why anti-cancer treatments involve targeting telomerases. So, the story of telomerase is the story of one tiny eraser with enormous implications. Understanding how it works can unlock new ways to combat aging and fight cancer. Thank you for watching.